So we've learned how to solve systems of equations by graphing. And some of you are going to be watching this after having watched how to solve it using substitution. Some of you are going to learn this one first, and this one is called elimination. Okay. So what we're going to do here is we have two equations, 2x plus 3y equals 11, and we have negative 2x plus 5y equals 13. Okay, we have two lines. We could graph this if we choose to. Another method here is just called, like I said, is called substitution. So what I'm going to, or elimination here. So what I'm going to do is I'm going to take these two equations and I'm going to line them up and I'm going to combine them together, okay? And what I'm looking for here is I want to add the two of them together so that one of the variables cancels each other out. So right now what I can do is I can take 2x plus 3y equals 11 and I'm going to add the whole thing here, right? Because I know that this side and this side are equal, okay? I can add this and this because they're saying the same thing, okay? It's sort of like this. If I have, if I say that x plus 5 is equal to 10, no, we'll say 12, okay? I can add 7 to both sides and it will still be true, right? Because 7 is equal to 7. I can combine these, okay? Well, this is just a more complicated way of saying this. This side here and this side here are the same. They're equal to each other. So I can add it to this without actually changing anything. So this one is actually already set up where 2x and negative 2x, when I combine them, will cancel each other out. So as I add these two equations together, these cancel out, and now I look at my y. We'll have positive 3y and positive 5y, and when I add those together, I'm going to get 8y. And then here I have 11 and 13, and when I add those together, I'm going to get 24. Well, now I can just divide by 8 on both sides, and I can get that y, excuse me, we get y is equal to 3. Okay, so now what we're going to do is we're going to take that and we're going to just plug it into one of these other equations, and I'm going to use this one up here because I don't want to deal with the negative there. So we'll do 2x plus 3y equals 11, and I'm going to take y, right, 3, and I'm going to plug it in there. So we'll do 2x plus 3 times 3 is equal to 11. So I get 2x plus 9 is equal to 11. I'm going to subtract 9 from both sides. And I get 2x is equal to 2. Divide by 2, divide by 2. And we know that x is equal to 1. Okay. Well, let's go ahead and check this. Let's plug it into both of these equations. And let's make sure that it actually works. So let's do the first one there. So we'll do 2 times 1 plus 3 times 3. Does that equal 11? Well, this is 2 and that's 9, and that does work. Okay, let's try the other one. We got negative 2 times 1 plus 5 times 3, and we're going to say, does that equal 13? Okay, and notice every time I do this, I always put parentheses for the variable, and then I just plug whatever in. I plug it into the parentheses, and you'll see, because sometimes if you have a negative answer, if y or x is equal to some negative number, it makes it easier. Okay, so then negative 2 times 1 is negative 2, plus 15 is 13. Does that work? Yes, it does. So x is 1 and y is 3. And if I were to graph these, you would see that they overlap, or the two lines intersect at 1, 3. All right, so that's how we use elimination. Let's try another one here. So I've got 4x plus 3y equals 2, and 5x plus 3y equals negative 2. Now, when you look at this and you're lining them up, okay, we don't have anything that's going to cancel right away. However, what I can do is I can change. There's two things here. One is you could subtract, okay? We could take 3y and we could subtract 3y because it's the same amount, and then it'll cancel out. I find that when students do this and when I do this, I make all kinds of mistakes when I subtract. So I always try to add, and so what I will do is I'm just going to take this first one here, and I'm going to multiply everything by negative 1 or make everything the opposite. So we'll do, let's rewrite it. We'll do negative 4x plus negative 3y is equal to negative 2. And then I'm going to take the bottom one, 5x plus 3y is equal to negative 2. And now what I'm going to do is now I'm going to add these two together. And when I do that, the y's cancel each other out, and I'm going to be left with 1x is equal to negative 4. Well, that was nice. It just ended up with 1x. Well, then let's go ahead and we'll plug this back in. So we'll do 4 times negative 4. Notice I put the parentheses and then this directly inside of it. Plus 3y is equal to 2. Okay, well, let's check it out. 4 times negative 4 is negative 16 plus 3y is equal to 2. I'm going to add 16 to both sides. And I am left with 3y is equal to 18. Divide by 3 on both sides, and you get y is equal to 6. Okay, that's one of them. Okay, and then we know that x is equal to negative 4. All right, well, let's check this out. Let's check out our solution here, make sure they work. So we'll do 4 times whatever x is plus 3 times whatever y is, and we'll make it equal to 2. So we know that x is negative 4, and we know that y is 6. So we get negative 16 plus 18. Does that equal 2? Yep, that works. Now let's try the other one. 5 times negative 4 plus 3 times 6. Does that equal negative 2? And I get negative 20 plus 18 is equal to negative 2. That one works also. All right, looking good. Why don't you go ahead and you try doing this one. Now, the first thing you're going to want to do is get the x's and y's on both sides. Okay, make sure put them in standard form, line them up, see what happens from there. Go ahead, try it. Okay, well, let's rewrite this. Let's rewrite this so that we get 8x minus 4y is equal to negative 4. Now, this one I'm going to do is I'm going to put the x over on the other side, so I'm going to get negative 3x plus 4y is equal to 14. Okay, now, this is not in standard form, but I'm not going to have to worry about it right now because I'm not looking to have it in standard form. What I'm really looking for is x and y and a number so that everything lines up. Okay, and I have a negative 4y and a positive 4y, and when I add this, those will cancel each other out. So I'm going to go ahead. These cancel each other out, right? You're looking for opposites. You're looking for additive inverses of variables, right? If I have negative 4y here, I'm going to need a positive 4y to get rid of it. Or if I have 8x here, I'm going to need a negative 8x over here. Well, in this case, the y's cancel each other out. So then I'm going to add 8 and negative 3 make 5x. Negative 4 and 14 make 10. I'm going to divide by 5, and I get x is equal to 2. All right, let's take one of these other ones. Now, I'm going to use this one since it's already set up nicely for me. So I'm going to do 4y is equal to 3 times 2 plus 14. 4y is equal to 6 plus 14. 4y is equal to 20. Divide by 4, and y is equal to 5. So I've got y is equal to 5 and x is equal to 2. Let's go ahead and we'll plug those in here. So we'll do 8 times 2 minus 4 times 5, and we'll see if does that equal negative 4. Well, that's 16 minus 20 is equal to negative 4. Negative 4, yeah, that works. Okay, next one. 4 times y is 5 is equal to 3 times x is 2 plus 14. So we've got 20 is equal to 6 plus 14. Does that work? 20 is equal to 20. That one works also. Okay. So my solution would be 2 x is 2 and y is 5. If I were to graph that, they would be two lines that would intersect at 2, 5. All right. Go ahead. You try this one. Go. All right. This one is a little trickier. So again, let's make them 2x plus 5y equals 12. Let's line up. Let's get them all lined up so we have x's and y's on the same side. So I'm going to take the 4x. I'm going to move it to the other side. It becomes negative 4x. Notice I put it in front, right? Line it up. And then this is a positive 5y is equal to 6. Okay. 2 and 4, these are not additive inverses. They won't cancel out. And then 5 and 5, those won't cancel out either. So I'm going to make one of them totally, like I'm going to change, well, let's see. I'm going to multiply all of one of these by negative 1 so that 5 positive 5, we'll either change negative 5 here or negative 5 here. And it doesn't really matter. We'll do the, I don't know, we'll do the bottom one. That makes, if I multiply the bottom one by negative 1, then this becomes positive, and I'm more, that'll be nice. If I do this one by negative, then this will become negative, and then I'll end up with a negative x. I'm going to try to avoid that. So let's take this one here, and we'll multiply it by negative 1, or change all of them the opposite, and you get 4x minus 5y is equal to negative 6. Okay, and then we'll put the other one underneath it. 2x plus 5y is equal to 12. And we'll combine these. These cancel out, and I'm left with 6x is equal to 6. So x is equal to 1. Okay, so you can use either one of these to find out what y is. I'm going to use this one because it's already sort of set up for me. So we'll do 5y is equal to 4 times 1 plus 6. So 5y is equal to 4 plus 6. 5y is equal to 10. Divide by 5, y is equal to 2. Okay, there's one. Here's another one. Let's go ahead. We'll check our answers. So we'll do 2 times 1 plus 5 times 2. Does that equal 12? 2 plus 10 equals 12. Yes, it does. And then we'll do the other one. 5 times 2 plus, oops. Does that equal 4 times 1 plus 6? That one looks like it's going to work too. So we'll get 10 is equal to 4 plus 6. Yep, that works. So there you have it. Okay. Make sure you bring your notes with you to class on Monday or Wednesday, depending on when you're supposed to watch the video. And we will discuss in class. You'll have plenty of time to work and practice and talk it over with your classmates. Okay.